Okay, this lesson is going to tie directly back to last week's where we started exponential functions. Exponentials were functions were these graphs that stay really close to what was called the asymptote and then kind of shoot up at the end. You may see them look the other way. They may look like this, where they go down at the end, and we're going to talk about that in just a minute. But what you need to remember is that these are in the form y equals a to b to the x plus c. None of the stuff that we are doing this week has a c, which means our asymptote is always going to be 0. Okay? So we've got a times b to the x. That means that b is the number inside the parentheses. So here we've got b is 2. And if there's not a number, we know that a is 1. A was my initial value. So that's what it's going to be when I cross the y-axis. So you can see right here that that is in fact 1. And then b is going to be what that multiplies by every time I move forward. So we've got 1, and then we're going to multiply that by 2. 1 times 2 is 2. We're going to multiply that by 2. 2 times 2 is 4. We're going to multiply that by 2. 4 times 2 is 8. So as I go forward, my next point over, so I go over 1 and up, should be 2. Then I move over again. I see that I go up to 4. When I go over again, I should multiply by 2 and I get 8. And that's what we're looking for. So I can see that this graph does follow that pattern. On the desmos, they're going to give you a couple points and they're going to be asking you to find the graph. We're going to try this on a couple more, let you see it, and then I will show you how to do one off the desmos, like that. So once again, we're going to look. A here is the first number, that is 3. B is what I'm changing by, and that is 2. So my initial value should be 3, and then I'm going to keep multiplying by 2. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And I can tell it's an exponential function because it's multiplying. So let's come over here. First point should be 3. That is true. Next point should be 6. Cool. Next point should be 12. Looks like we would have hit it. And then it goes off the graph. That is okay. These get really big really fast. The bigger that my b is, the faster it's going to get massive. Let's go ahead and look at the third example. Once again, a is in front, so a is equal to 3. B is second, so b is also equal to 3. So I start with 3. And then I'm going to multiply by 3. 3 times 3 is 9. Multiply by 3. Or multiply by 3 one more time. And you're going to notice that that isn't going to fit on the graph. 27 didn't even fit on this graph. So let's go ahead and check. 3 should be my initial, so it should be on the y-axis. Then if I go over 1, I should be able to go up to 9. That is my next point. And then I can't reach 27, so I'm good to go. This one is a decreasing graph or a decay when we talk about exponential functions. I can tell it's a decay because b is less than 1. So you can see that this fraction 1/2 is b. That tells me that I'm going to have a decay. And rather than multiply by 2, I'm going to be dividing by 2. So a is equal to 3. B is equal to 1/2. That tells me it's a decay. And you should have practiced this last time. If you didn't finish x2, you need to finish x2. That's going to help you out here. And that is going to be one of your mandatory grades. Okay, so let's go through. I start with 3, And then I'm going to say, what's half of $3? Well, half of $3 is $1.50. And then I can say, what's half of $1.50? That would be 75 cents. And I'm going to go over to my graph. As I go forward now, it should be following that pattern because I am saying half of. So I start at 3, go over 1, and I should go down to 1.5. Just like we talked about in class, if it's a graph, I can never get exactly 1.5. I can check and make sure. This is actually a graphing calculator, so that's going to actually be 1.5. Let's go over again and go down. That definitely looks like it's right at 0.75. So it looks like we have the right graph for our function. Last one where I am showing you the graph and the function, and then we'll see what the desmos is going to look like. We've got A is equal to 1/2. B is equal to 4. The reason I wanted you to see this one is because sometimes people get confused about this fraction being in the front. This is still what my y-intercept is. So think about that as 0.5. We know that 0.5 is half. So it's going to go halfway between 0 and 1 when it crosses the graph. Now I'm still going to be doing the same thing as before. We're going to start with 1/2 since that's our initial value. If you prefer to write 0.5, then you are more than welcome to. But what we're going to do is multiply by 4. So the first one is probably going to be the hardest because we have to multiply by 1/2. But you guys should be perfectly fine saying that half of 4 is 2. And that's how you should always think about multiplying by 1/2. Now we're just multiplying by 4, so 4 times 2 is 8. 8 times 4 is 32. And we could keep going from there. Let's look at our graph. 2 should be next. Went over 1, went up to 2. Now I should be able to go up to 8. And the next one will be 32, and it looks like it is growing quite quickly. So we'll definitely be at 32. Now this is more what the desmos activity is going to look like. You can see that there are 2 points here. One of them is on the y-axis and will help me determine my y-intercept. That is obviously the red point here. And then the other one is going to help me determine what I'm multiplying by. So let's start with A. A is where I cross the y-axis, and I can see that that point is 2. Now we're also going to need B. So what I need to do is figure out what did I do to get from this point to the new point. So this is 8. So I went from 2 to 8. To get from 2 to 8, I multiply by 4. That means that B is going to be 4. So all you're going to have to do is type in this equation. A is 2, B is 4, and I put B to the x. So this is what I would type in. And the desmos will actually draw the graph through the points and tell you if you are correct or not before you move to the next question. We've got another one. So once again, we always look for A, and then we use A to figure out B. So when I look here, A is 1, 2, 3. And then I look at the second point, and that is going to be at 6. So I go from 3 to 6. To get from 3 to 6, I multiply by 2. So I'm going to type into desmos y the initial value, which was 3, times the rate of change, what we're changing by, which is 2, to the x power. Last one, this time we are going down. Remember, that means that B is going to have to be less than 1, which just means that I'm going to put 1 over whatever that number I'm dividing by is. So we're going to start by finding A again. A is 6, because that is where the red dot is. Then I can look down here, and this is at 3. So to get from 6 to 3, I'm going to divide by 2. Another way to write dividing by 2 is 1 over 2. So this is going to be my fraction. So y equals what I start with, my initial value, 1/2 to the x. That's what I should type in desmos. And once again, if you are correct, the line is going to go straight through those points, and it's actually going to put a green check mark beside it so that you can be sure that you are correct. It will also allow you to change it if you are incorrect. And there's only one that's really difficult. Make sure you're trying improper fractions when you get to that one. Okay, there is only one that's kind of difficult, and that one is a improper fraction. If you're picking decimals, it will not give you the exact right answer. Okay? But if you get close with your graph, I will go through and count it correct, even though Desmos doesn't. Have fun. Good luck. Have a great day.